Assalamualaikum dan salam sejahtera to Dr. Faisal. First, I will introduce my group member. The first one is Akil Irfan bin Khairil Anwar, Nur Arman Adli bin Khalid, Intan Sazrin binti Kapli, Muhammad Izul Haziq bin Rahib, and lastly me, Muhammad Khairil bin Ushapudi. This is project penetration testing, our project. In this project, we will use websites such as Juice Shop to test the authentication mechanism. I will cover two parts in test the authentication mechanism, which is test password quality and test username enumeration. The password must have a minimum of 8 characters, at least 1 digit, 1 lowercase character, 1 uppercase character, and 1 special character. This is because website offers password assistant. It aids in creation of a secure password. The next one is test username enumeration. The process of creating a list of every legitimate username on a server or online application is known as username enumeration. If the program or server give an indication as to whether the username exists, it is become feasible. The first figure illustrates what happens when we utilize an unregistered email address. We are unable to reply to the security question at this time. The second figure illustrate what happened when we utilize a registered email address. We are able to reply to the security question at this time. As shown in our example, restricting user enumeration is achieved by guaranteeing that no site or API can access the system between valid and invalid usernames if there are no matching password. That's all from me. I will pass it to next member, which is Izul Haziq.
Next is to test resilience to password guessings. The reason password guessing resistant is important is because it makes it easier for hackers to have access victims' account by guessing online passwords. They do this by getting their victims' personal data, including names, addresses, password for others' account, and personal identifiable information. Based on the first figure, we create a word list of potential passwords by entering the email addresses that we have already guessed via usernames enumeration in order to demonstrate resilience to password guessings. Next, you use second password advice from the Jushop website to define the criteria as seen in the second image. We are unable to access the account because the created password does not match the original password. This indicates the password we made are secure enough to prevent any access by hackers. The next is test any account recovery function. Getting back access to an account for all of its associated data and rights is known as account recovery, usually required the use of secondary or backup authentication method. We use the forgot password features in the system, and backup authentication is the security answer. When we enter the wrong password to the questions, the first and second figures display. Next point is a test remember me function. By checking the remember me checkbox and accepting the save password functions, as illustrated in the second figure, we are enabled to remember features. The third example illustrates how when we return to the website later, the password and email already entered. That's all for me. I pass to the next person. Thank you.
For the test the session management mechanism, the first one is test token predictability, where the whole token will be decoded using base64. We will highlight the whole token and set it to decoder as shown in this figure. In the second figure, the token will be decoded using base64 and then the decoded token will be changed to text form. From the text here, we can see the type JWT, the algorithm RS256, the username, the password, and also the email. Passwords shown here are encrypted and can be decrypted using algorithms shown in decoded text. Next figure is when we try to decrypt the password. Yellow decode using base64, blue password decode using hex, while green password decode using ASCII hex. So to decrypt, a different algorithm produces a different results and the password remains encrypted since it remains in a secure state. The second one is check for insecure transmission of tokens. So the figure demonstrates that token is being transmitted in plain text. Ideally, tokens should be encrypted using HTTPS. However, the exposure here makes them easily readable by anyone intercepting the communication. This vulnerability could lead to account hijack, data theft, and unauthorized actions, posing a serious threat to user security.
Hello everyone. Today I will walk you through two critical security tests we conducted. Number one is check mapping of token to sessions. First, let's look at token mapping. Tokens are unique identifier generated for user session. We analyze token from two different accounts, and here is what we found. Some part of the token are identical while others are unique. This design is intentional. The share part are used for system authentication, ensuring consistency across the platform. Meanwhile, the unique section differentiates each user, ensuring that token can be reused across accounts. This approach strengthens security and ensure every session is properly authenticated. Next, for the test session termination. We tested session termination, a critical security feature. Here's how it works. A user login into the application, perform action, and their session is associated with their account as seen in the author field, which display their email. After logging out, we tested that happens if someone tries to reuse the session URL in another browser. The result, the system invalidates the token and the session is marked as anonymous. This means the session is securely terminated, preventing unauthorized access to the account. That's all from me, thank you.
Okay, the next part is test for input-based vulnerabilities. So, the first one is we need to test for SQL injection. So, what is SQL injection? SQL injection is a vulnerability where attackers manipulate input fields to execute malicious SQL query. This can lead to unauthorized access, data leakage, or even full control of the database. So, let's look at how we test for SQL injection vulnerability in a login interface. The first one is we are going to check if the login interface are vulnerable to SQL injection. So, we need to analyze the query structure, which typically looks like select from user, where username and password. So we simply try to change the query by adding new argument like always true. Example for the new query is select from user where username admin or 1 equals to 1 and the password is 12345. As a result, we successfully log into the admin account, proving the login interface was vulnerable to SQL injection. The next part is we need to test for XSS injection. What is XSS? XSS is cross-site scripting. That means it's another input-based vulnerability that allows attacker to inject malicious script into web page. The script execute in the context of the user browser. Here, how we test for XSS vulnerability in search field. Firstly, we need to carefully enter the code I from src equal to javascript alert xls. The code is for to inject the javascript code. After submitting the payload, alert box was triggered. Indicating the script executes successfully. For the result, this confirmed the search field was vulnerable to access attack, which could allow attackers to execute arbitrary script or steal user information. The last part is a suggestion to avoid vulnerability. For this part, we suggest 3 to avoid the vulnerability. The first one is use HTTPS. Let me summarize it. Use HTTPS for ensure secure communication by encrypting data transmission between the client and the server. The second one is data encryption. Encrypt sensitive data both in transit and at rest to ensure it remains secure. The last is security testing. It is for regularly conduct vulnerability assessment, penetration test, and code review to identify and fix potential weakness. So that's all from us. Thank you for watching.